Hello again, students. We are back. So this is going to be the last video in this sequence on the law of sines, in which we'll do applications. So let's start by just reminding ourselves what the law of sines says. The law of sines says that if you have a triangle with side lengths, big A, big B, big C, and angles, little a, little b, little c, where the letters correspond to opposites. So angle little a is opposite side big A, angle little b is opposite side big B, angle little c is opposite side big C. If you're in that situation, then A over sine A equals B over sine B equals C over sine C. So let's see what we can do with that. So that's an abstract fact, but you often want to know distances between things. If you have 3 points, the distances between them work out to be a triangle. So let's use that. So, the situation. You and Katrina Allen stand in a field precisely 30 feet apart and witness a flying saucer pass overhead. This triangle summarizes your positions and the angle at which the flying saucer flies overhead. How far up is that flying saucer? How far from you is it? So let's try to work that out. So instead of these ambiguous things just labeled with question marks, let's assign these things variable names. So let's call this, I don't know, A. Let's call this B. And this is the hypotenuse, so let's call it H. So let's try to walk this out. So I want to know what the side lengths A and B are. That's essentially saying that I want to solve this triangle. And this is a triangle in which I know 2 angles and 1 side. The algorithm that you should follow in this circumstance is first, find the remaining angle, then use the law of sines to find the sides you're interested in. So let's try to figure out this remaining angle. Let's give it a name. Haven't used purple in this picture yet, so I guess this had better be the angle labeled little c. So how can I find that? Well, what do the angles of a triangle add up to? Pi radians, or this situation is in degrees, so 180 degrees. So the fact I know. So step 1, find little c. So c plus 70 degrees plus 85 degrees is equal to 180 degrees. Solve that for c. C is equal to 180 minus 70 plus, minus 85 degrees. So let's just look at that. 180 minus 70, I'm very slow, is 110 degrees. Minus 85 degrees, so 85 plus 10 would put me at 95, plus another 10 would put me at 105, plus another 5, so that's 25 degrees. So C is 25 degrees. Let's encode that in the triangle. That angle C is 25 degrees. Hi, cat. So now that I know that side length, let's use the law of sines. Let's use the law of sines to get A and to get B. Well, what do I know? Well, I know that A divided by the sine of the angle opposite is equal to the ratio of any side divided by the sine of the angle opposite. And there's a pair of an angle which I know and a side opposite, 25 degrees and 30 feet. So A divided by sine of 70 degrees is 30 feet divided by the sine of 25 degrees. I can solve that for A. I just need to multiply both sides by 70 degrees. A equals 30 times sine of 70 degrees all over sine of 25 degrees. And that's not something that you can compute by hand. I don't know the sine of 70 degrees. I don't know the sine of 25 degrees. But I can use a computer to get approximations. So let's do exactly that. All right, here we are. We're back. The computation has been done. While I was doing that, you missed out on something. The heaviest of the cats, Oreo, weighing in at about 14 pounds, jumped down about 4 feet from the top of the mattress on its side to the table and made a quite satisfying thunk, and then he ran off. That doesn't necessarily matter to you. So we can approximate that. This is not the exact value, 66.71. We could get more digits if we wanted to. Well, there's the approximation, 66.71. And let's put the units back. This is in feet. So the distance from you to the flying saucer is about 66.71 feet. Let's use the law of sines to get b. So in this case, we see b divided by sine of 85 degrees is equal to 30 feet divided by sine 25 degrees. B is then exactly equal to 30 times the sine of 85 degrees. You would multiply that over to the other side, and you are still dividing by the sine of 25 degrees. Well, using a machine again. $70.72 feet. Did I round correctly? Okay, it rounded to there for me. Nice, so there's distance A and distance B. Let's just review that problem and see if it addresses all the problems. Certainly we've solved the triangle. We're missing one result yet. We still need to determine how far above the ground that flying saucer is. That is, in this picture, we need to compute this side length h. Oh, hey, but I see a right triangle now. See a right triangle? Its hypotenuse is length a. I see an angle of 85 degrees. I want to know the height. Oh, trig functions will save me. Notice, I don't know that this side length is 30 feet. It is definitely not 30 feet. The whole base is 30 feet. I have no idea right now how far that distance is. So let's go ahead and use that. So, let's see. I see this. There's an angle of 85 degrees. This picture is not drawn to scale. Here is the side length A, which I have a formula for. This is a known. And there's H, the thing I would want to know. So I'm in a situation where I want to know the side length opposite. I know the hypotenuse. So going through the list of things, the list of different things in SOHCAHTOA. Let's see, ka doesn't do me any good. I'm not interested in this length, so I shouldn't use ka. So, sine is opposite over hypotenuse. I should use that. So let's use that. Sine of 85 degrees equals opposite over hypotenuse. So, I want to know what the hypotenuse, well, I don't want to know what h is, not the hypotenuse. I want to know what the height of the triangle is. It happens to be called h. H is equal to sine of 85 degrees multiplied by a. But I know what a is. A is this. I'm going to use the exact formula instead of the approximation in order to avoid errors from propagating. This is equal to 30 times sine 70 degrees times sine 85 degrees all over sine 25 degrees. There's an exact value. Notice none of those angles are angles that I see in the unit circle, so the best I can do is an approximation. The height is, well, let's use a machine. Here we are. Looks like it is 66 feet above the ground. Wonderful. And that completes the problem, right? What did we want to know? We wanted to know how far it is from you, that's the side length A, how far the frisbee is from Katrina Allen, that's the side length B, and how far it is above the ground, that's the side length H. We've just computed all of those. I guess I should be consistent in how I round. 66.43 feet. Nice. So, moving on. There's one last example that I want to do. Here it is. You and Zebulon Pike Jr. stand 50 feet apart, hence the 50 meters. There's you. There's Zebulon Pike Jr. You are looking towards a mountain. You are both armed with an ebony level, so you can measure the angle of elevation of a line of vision above horizontal. So you do exactly that. You look up to the top of the peak. Zebulon Pike looks up to the top of the peak. Your angle of elevation is 30 degrees. His angle of elevation is 35 degrees. Let's determine the height of the peak. And here's what I suggest you do before we do anything. Solve this on your own, and here's the strategy you should use. Just look at this picture, find anything in the picture that you can compute. Eventually, your goal is this, but you can't compute it directly. You'll need to do a bunch of geometry. You'll need to say, oh, well, I know what this angle is. I know what this angle is, so I can figure out some side lengths. So, pause the video and do that. Okay, nice. You have done. Let's solve it together now. So here's the philosophy that I'll take. So if you look right here, this whole angle is 180 degrees. So that means that whatever this angle, let's call it A, is, plus 35 degrees has to add up to 180 degrees. So let's start with that. A plus 35 degrees is half of a revolution. That's 180 degrees. Subtracting 35 to the other side, you get A is equal to 180 degrees minus 35 degrees is, well, if I can do arithmetic correctly, that's 145 degrees, I believe. So this side length is 145 degrees. So now, looking at this triangle, I know some information about it. I know, let's see, I know this angle, I know this angle, I know this side. Hey, that's the situation in which you can use, well, first find the remaining angle, so we'll find that angle. Once we know that angle, we'll know all three angles and we'll know one side. That's a situation where you can use the law of sines. So let's follow that through. Let's give this angle a name. Let's call it B. Well, I know that 30 degrees plus 145 degrees plus B is 180. These two add together to be 175. So that means B is equal to 180 degrees minus 175 degrees. That is 5 degrees. Did I do that correctly? You have no way of answering me. So that angle B amounts to 5 degrees. Cool. Well, now I know all three angles, and I know this side. Let's just use what I know to find one of the other two sides, either this one, or that one, or both. I'm only going to do one, because that's all I'll need. And then we'll go from there. Maybe I'll aim for this one. You'll get the same answer. Well, presumably you'll get the same answer even if you follow the opposite approach. So let's try to determine that side length. It's opposite the angle that I called little a, so I will call it big A. So by the law of sines, I know that A divided by the sine of 145 degrees is equal to 50 meters. 50 meters divided by the sine of the angle opposite, divided by the sine of 5. That's not a very good looking sine of 5 degrees. So that means that A must be equal to 50 times the sine of 45 degrees divided by the sine of 5 degrees meters. And I'm not going to get a decimal approximation because I don't care about that side length. So I don't care about its decimal approximation. I'll use the exact value in some other formula later on. So the point is, now this A is known. Oh, cool. But now, check out... Ooh, I wonder what happens when you highlight on top of highlighting. What happens when you look at this big right triangle? Well, it's a right triangle. You know the hypotenuse. You know that 30-degree angle. You can use that to figure out the height. Let's call that x because it's the thing that I want to know. Doesn't matter what you call your variable names. So, let's see. I guess that's so katoa. It looks like I'm using so. So, sine of 30 degrees is equal to opposite divided by hypotenuse. I can solve that for x. X is equal to A times sine 30 degrees times oh no, that's A times the sine of 30 degrees. Well, I know what A is. A is 50 times the sine, not of 45 degrees, Chris, sine of 145 degrees. That's the type of mistake that can cost you in the end. That should have been a 145 degrees because that's this angle. So I know what A is. X is equal to 50 sine 45 degrees, 145 degrees. Divided by sine of 5 degrees. And well, I know what the sine of 30 degrees is. It's on the unit circle. That's a 1/2. I know how to divide the 1/2 into 50 at least, so I should simplify as much as I can. 25 times sine 145 divided by sine 5, all in degrees, in meters. Now, I actually care about how big x is. X is supposed to be the height of this mountain. This will be approximately, and now I'll just plug that into the machine. All right, we're back. So, plugging that in, 25 times the sine of 145 degrees divided by the sine of 5 degrees is somewhere around 164.5 meters. It's not much of a mountain, I guess. It's a pretty good hill, though. Cool. So, what's the takeaway here? If you have a problem that involves triangles, even if they're non-right triangles, that you need to solve, chances are good that you may well need to use the law of sines to address that problem. There's a chance that maybe the law of sines won't be sufficient. It could be that you should use the law of cosines, which will happen in, of course, the next video. I'll see you then.